Good afternoon, good morning, good evening, whenever you're watching this. This is 1.8 function values, domain and range. For a function, the set of possible x values is called the domain. This is also our input, and then the set of y values is called our range or our output. So your y is your range or your f of x, and the domain is your input, your x. The function is like a machine in that for any given input value from the domain, the function produces the unique output value, the range. So when we put in a domain of A, we get f of A. Put in domain of B, we get f of B. Domain of C, we get f of C. D, f of D. A discrete domain is a set of input values that consists of only certain numbers in an interval, whereas a continuous domain consists of all numbers in an interval. Likewise, the range of a function may be either discrete or continuous. A domain of counting numbers from 1 through 5 would be discrete. A domain of real numbers from 1 through 5 would be continuous. So our discrete is the individual dots or individual points, 1, 2, 3, 4, 5. So when we graph a discrete, it's only points. When we do a continuous, it starts on 1 and goes to 5 and ends. And it's all the values in between. We can often express a continuous domain or range as a compound inequality. If the domain or range extend infinitely in the negative or positive, we can also say it goes from negative infinity or infinity. So for example, if f of x equals x is defined for the domain of all real numbers, it would go from negative infinity is less than x is less than infinity. Then the range would also go from negative infinity to infinity. If we wanted to express this continuous function right here, it would be from 1 is less than or equal to x is less than or equal to 5. On a graph, an open circle can be used to show an endpoint that is not included. Just as when we saw graphing inequalities, an open circle means the point is excluded, but a closed circle means the point is included. So that's like when it's really, really close to that value, but not exactly that value. The linear graph below shows the partial graph of the function f of x equals 2x minus 1. Determine the domain. So when I'm looking at my domain, remember, is always my x values. So it starts at negative 2, and negative 2 is included. X equals negative 2 included, because that's a closed circle. So it goes from negative 2 is less than or equal to x, is just less than x equals 4, is not included because that's an open circle. So it's just less than 4. And it's similar when I do my range. So this is y equals negative 5 is included. So negative 5 is less than or equal to y is less than 7. Because 7 is not included because that's an open circle. So example, determine the domain and range for this graph. So if I look at my domain, all my x values can be included. So I could say that negative infinity is less than x is less than infinity. However, my range is never going to be negative. So that means I'm going to say 0 is less than or equal to y is less than infinity, because it's never going to be negative. When I take the absolute value of x, I'm never going to get a negative answer. I could also say that this one is just y is greater than or equal to 0. Determine the domain and range for this function. So if we look at the ends of this, there is no circle indicating, therefore we assume it's a closed circle. So my domain goes from -2 to +3. Domain is really just happening with x. So our domain goes from -2 is less than or equal to x because is less than or equal to 3. And those are less than or equal to because those are closed circles. Our range, our smallest y value is -5, and our largest y value is 4. So range goes from -5 is less than or equal to y is less than or equal to 4. So the x is always the horizontal change, the y is the vertical change. So now here, our example, find the range of f of x equals 3x plus 10, where f of x is domain is defined as 5 is less than or equal to 10, is less than or equal to x is less than 10. So what we're going to do is we're going to first find f of 5 by substituting. So it's 3 times 5 plus 10 equals 25. Then we find f of 10, and it's 3 times 10 plus 10. So that's 30 plus 10 equals 40. So our range is equal to 25 because it was equal to x. So 25 is less than or equal to x is less than 40. It's only less than 40 because it was only less than 10. The effective pH. So these are our additional practice problems that we're going to work on in class tomorrow. If you have any questions, please bring them to class.